Okay, our next piece is getting to this notion of an amplitude. So I have one period of the sine curve drawn here. Now this applies to the entire curve on its entire domain, but I'm going to talk about it only on just this period, from 0 to 2 pi. Amplitude is a fundamental notion in the sine curve and in any periodic function, but especially in the sine and the cosine curves. Now, we saw that the peak in this case is at 1, the trough at this case is at -1. That total distance is 2. The amplitude is half of that total distance. The distance between the minimum point and the maximum point, that distance is the amplitude. In the basic sine curve and the basic cosine curve, those are always fixed values. And so in this case, for the basic sine curve, the amplitude is the distance between either the peak and the axis or the axis and the trough. But in either case, that distance is 1. The amplitude of this function is 1. Similarly, if we have the cosine curve, so here's pi, 2 pi, 3 pi over 2, pi over 2, -1, 1. Remember, sine starts at the node, whereas cosine starts at the peak. Sine starts at the node, cosine starts at the peak. Cosine looks like a valley, if you will. But the amplitude is the distance between the peak and the axis. In this particular case, that distance is 1 as well. So the amplitude of the cosine, basic shape cosine curve, is also 1. Now, the amplitude of a function can change depending upon how the function itself changes. Consider this function. Consider the function 4 times sine of x. Now, the first time we do this, we're going to use our little grid, but once we see what's happening, we won't need this grid anymore. At x equals 0, so let's draw our sine curve. This is the ordinary sine curve here. 1, -1, there's pi, there's 2 pi. Sine starts at the node. So that's the ordinary sine curve. I'm going to draw this graph in red, and so we'll be able to see the difference here. When x is equal to 0, I want, not sine of x, I want 4 times sine of x. So what this means is first take the sine as if the 4 were not present, and then multiply by 4. So whatever the value we get, we multiply it by 4. Well, sine of 0 is 0. Sine of 0 is 0. That's what this graph indicates. 0 times 4 is 0. So the red curve also passes through the origin. But here's where it's different. If we did not have the 4 present, we would be using this curve, and at pi over 2, the sine of pi over 2 is 1. Sine of pi over 2 is 1. So what we want is 4 times sine pi over 2. But that means 4 times 1, that's 4. So at pi over 2, the function value is not 1 anymore. The function value is at 4. 1, 2, 3, 4. So the function starts at the origin, has to pass through pi over 2 comma 4, but look what happens at pi again. At pi, this is 4 times sine of pi. Well, the ordinary function says sine of pi is 0. The function value is 0. Right? The y-coordinate function value is 0. So this is 4 times 0. That's back to 0. And so it must pass through this point again. And then what happens at 3 pi over 2 is similar to what happened at pi over 2, except that it's negative. This is 4 times sine of 3 pi over 2, which is 4 times negative 1, because sine of 3 pi over 2 is negative 1. But we multiply it by 4, this is now negative 4. So 1, 2, 3, negative 4. And then it's not too hard to see that at 2 pi, the function value is 0 again. And these numbers would continue to cycle through in both directions. And so the graph looks something like this. What happens when you multiply this function with a multiplier in front or outside this function? What that corresponds to is you multiply the height by that much. So if this is 4, it multiplies, notice it's 4 times as high. The amplitude, this distance, is now 4. This coefficient is the amplitude of that function. And it indicates the distance between the nodes and the peak, the distance between the nodes and the trough. So the amplitude is this coefficient, and that tells how tall the curve is. Now, if we know that, then it shouldn't be too much of a challenge to sketch the graph of a wide family of functions now, because there's nothing magic about 4. What if the multiplier had been 6? Is it clear what the picture would have been? Let's draw this in purple. Instead of multiplying it by 4, the amplitude is being 4, here the amplitude is 6. And so the nodes would again stay the same, but now the peaks would be up at 6, and the trough would be at negative 6. So that would be the picture. There's nothing magic about 4, there's nothing magic about 6. Neither is there something magic about the multiplier being greater than 1. Suppose f of x corresponds to 1/2 sine of x. Now, the amplitude, I'm going to draw this in blue, the amplitude here is 1/2. The distance between the axis and the peak is only 1/2. And so the nodes stay the same, but the peak and the trough are only 1/2 and negative 1/2 respectively. And so instead of stretching, we've actually compressed the function vertically. So this multiplier in front is the amplitude. If you're ever asked to find what is the amplitude of a function, pick off the coefficient in front. What does that do to change the function? It stretches it if the multiplier is greater than 1. It compresses it if the multiplier is less than 1. One last piece. What if the multiplier is negative? Let's suppose it's negative 2 sine of x. Remember what a negative multiplier does to the basic shape square function. Instead of opening upward, it opens downward. So it essentially makes the graph upside down. What was up becomes down and vice versa. But amplitude is a distance. Distance cannot be negative. Strictly speaking, the amplitude is not 6. Strictly speaking, the amplitude is absolute value of 6. Strictly speaking, the amplitude is absolute value of 1/2. Up here, the amplitude is the absolute value of 4. And so here, the amplitude is the absolute value of negative 2, which is 2. That's just telling us the distance. But the negative tells us that it must be stretched by a factor of 2, and yet what was up becomes down, what was down becomes up. And so the nodes stay the same, but now we multiply by negative 2. So positive 1 becomes negative 2, negative 1 becomes positive 2. So if the multiplier is negative, that causes the function to be reflected across the x-axis. What was up becomes down, what was down becomes up. And it still is stretched by that factor of 2. So the coefficient determines the amplitude. Strictly speaking, the amplitude is the absolute value. Amplitude is a distance. Amplitude is not negative. The amplitude of this function is not. It is not -2. The amplitude of the function is 2. So, now if you know the amplitude in terms of the equation, you know what happens to the picture and vice versa.